Hello, we're going to get started on section 6.2, multiplying and dividing radical expressions. The first part we have is multiplying radical expressions. Something that we need to know before we can multiply radical expressions is the roots, so this one's the cube root and this one is the square root, has to be the same in order to multiply them. I kind of think of them as like terms. They're not the same, they're not like terms, we can't multiply them. So for this first one, one's a cube root, one's a square root. They're not the same, so we cannot multiply them because they have different roots. Let's go to the second one. We have the cube root of -4 times the cube root of 2. Notice the roots are both the same, so we can multiply those. So -4 times 2, we get -8. The cube root just stays the same, so then we have the cube root of -8. And we can either put that into our calculator. How we would put that into our calculator is if we click this math button, the cube root is that fourth one down. Click enter, and then we put -8, click enter, and we get it's -2. So the cube root of -8 is -2. Another way that we can think of that, think of our factor tree for 8 is 2 times 2 times 2. It's -8, so each of those would have to be negative. And then since we have 3 of them and it's a cube root, we can bring out one pair of them, or one group of them, and we get that -2. For the next one, we have the fourth root of 7 times the fifth root of 7. Notice how we have the fourth root and the fifth root. The roots are different, so we cannot multiply them. Notice back on number 2, what's underneath of the radical sign is not the same. Make sure that does not matter. Just the roots have to be the same in order for us to multiply them. This next one is going to be simplifying radical expressions. So to start off with, we have the cube root of 54x to the fifth. So we're going to do a bunch of factor trees. Notice in this first step, I did the factor tree for 54. I broke that down to all its prime numbers. So if we do 54, we can have, it is 6 and 9, 6 is 2 and 3, and then 9 is 3 and 3. So we have 1, 2, and 3 threes, and then we have x to the fifth. So we have a total of 5 x's. If we expand that out, it's the cube root. So we're going to be putting them in groups of 3. So we have one group of 3 here, one group of 3 here. So we can bring out 1 3. We can bring out 1 x. So we're going to multiply that 3 and the x together to get 3x. And then the cube root stays the same. And then we have this 2 and these 2 x's that we don't have a group of 3 of them. So we keep that underneath. So then 3x times the cube root of 2x squared would be our final answer. This next one is another cube root, so we're going to have to break it down, do our factor tree, put them in groups of 3. So we broke down 128. Notice how we have 7 2's when we break that down. And then we have 7 x's. We're putting them in groups of 3, so we have one group of 3 here, one group of 3 here, one group of 3 here, and one group of 3 here. So we can bring out this 2, this x, and this x. So then we're going to multiply all those together. So we have 2 times 2, we just get 4. X times x is x squared. And then what we don't have a group of 3 of, we keep underneath the radical sign. So times the cube root of, and then we have this 2 and this x left over. So times the cube root of 2x. Now this next one, we're going to be simplifying a product. So we're going to be combining what we've learned in the first 2 parts. So we have the square root of 72x to the third, y squared, times the square root of 10xy to the third power. Notice, first off, the roots are the same. They're both square roots. So we can go ahead and multiply those. So 72 times 10, we get 720. We have 3 x's here, 1 x here, so 4 x's. We're adding those exponents. We have 2 y's here, 3 y's here, so a total of 5 y's. Again, we're adding those exponents. And then we're just going to simplify it to like this above section. So then we do our factor tree for 720. You can see we get 2 times 2 times 2 times 2 times 3 times 3 times 5 for our factor tree. We have 4 x's and we have 5 y's when we expand that out. Now it's a square root. If it does not have a number here, then it's a square root, so assume a 2, that we're putting them in pairs. So we circle our pairs and then we bring out 1 in each pair. So then we go ahead and multiply those. 2 times 2 is 4, times 3 we get 12. And then we have 2 x's, so x squared, 2y, so y squared. And then we don't have a pair of our 5 and our y here, so we leave that underneath. So it'd be 12x squared y squared times the square root of 5y. Number 2, we go ahead and start simplifying this. So we have 45 times 35. Now if you don't want to go ahead and multiply those two numbers, I would just start doing your factor trees for them separately. So 45 is going to be a lot easier to do our factor tree. So we have 9 times 5, 3 times 3. And then 35, we have 7 times 5. Notice then if we multiply all these numbers together, then that's going to be the same thing as just 45 times 35. So sometimes it's just going to be a lot easier to do two separate factor trees than going ahead and multiplying them and doing one big one. So then we write all those numbers underneath. We have 5 x's here, 1 x here, so 6 x's. We have 3 y's here, 4 y's here, so a total of 7 y's. And then we're going to go ahead and put them in pairs because it's a square root again. So groups of 2, so we can bring out a 3 here, a 5, an x, another x, a y. So then we multiply those, 3 times 5, we get 15. We have 3 x's that we brought out, 3 y's that we brought out, and then times the square root of, we have 7 and a y left over, so square root of 7y. Now we're going to switch over to dividing. So the first one that I have for division is the square root of 18x to the 5th divided by 2x to the 3rd. They're both the square roots, so we can go ahead and divide these. So then we're going to think of it as one big square root symbol, and we're going to just start dividing to start with. So 18 divided by 2 is 9. We have 5 x's up here, 3 x's down here, so 3 of them are going to cancel out, so we have 2 x's left in the numerator. So then we get the square root of 9x squared, and then we're going to go ahead and simplify that just like how we did up here. The square root of 9 is 3 times 3. We have 2 x's, so x times x. When we expand that out, we're going to put them in pairs. So we have 1 pair of 3's, 1 pair of x's, so our final answer is 3x. Do a couple more division ones. So for this next one, we have cube root. They're both cube roots, so we can go ahead and divide these. So we're going to go ahead, first step, just start dividing them. 162 divided by 3 is 54. Then we have 5 y's up here, 2 y's down here. So if you're trying to get an image of that, we have 5 y's in the numerator, 2 y's in the denominator. So a y divided by y is just 1. Any number divided by itself is just 1. So those would cancel out, so then we have 3 y's left in the numerator. So we would have then the cube root of 54y to the 3rd power. Then we're going to do our factor tree for 54, and then we have 3 y's, so then we spread that out. We are putting them in groups of 3 because it's the cube root. So we can bring out 1 3 here, 1 y here. So we have 3y, and then leave the root the same, so cube root of, and then we just have a 2 left over, so cube root of 2. The next one, we have the square root of 50x to the 6th power divided by 2x to the 4th power. So we go ahead and divide. 50 divided by 2 is 25. We have 6 x's on top, 4 x's on bottom, so 4 of them are going to cancel out. We have 2 left on top. So we would have then, when we divide it, square root of 25x squared. We expand that out using our factor tree. So 25 would be 5 times 5. We have 2 x's. We put them in pairs of 2, so we bring out a 5, bring out an x, so our final answer would be 5x. Now the last part, we're going to be rationalizing the denominator. So this section is going to be a little bit different. When we try to divide, notice they don't divide as nicely as these top ones. So for this one, we're going to go ahead and, since we can't do 5 divided by 12, we're going to go ahead and just start expanding it out. So do our factor tree right from the start. And when we do that, we have 5. We can't break that apart. We have 2 x's. We have 2 times 2 times 3 gives us 12, and then 2 y's and a z. Now we cannot leave a radical in the denominator. It's okay in the numerator, just not in the bottom of a fraction. So what we want to be looking at is the bottom of the fraction. What do I need to multiply to get rid of the radical in the denominator? So it's the cube root, so I need to have 3 of everything. Notice I have 2 2's, so I need 1 more 2. I have 1 3, so I need 2 more 3's. I have 2 y's, so I need another y. And then I have 1 z, so I need 2 more z's. Okay, and then from here, we're going to, whatever we multiply across the bottom, we have to multiply across the top too. And then we should have in the denominator, if we start with that, groups of 3 of everything. No more radical. So we have a group of 3 2's, so we can bring out a 2. A group of 3 3's, so we can bring out a 3. That's how we're getting that 6. We have a group of y's, so we have that y. And then a group of z's, so that's how we get that z. Then if we look across the top, anything that we have 3 of, we're going to bring on out. We don't have 3 5's, 3 x's we don't have. We don't have 3 2's, 3 3's, a y, and z's, so we don't have 3 of everything or anything, so then we're going to just multiply them. 5 times 2 times 3 times 3 gives us 90. We have 2 x's, so x squared. We have 1 y, and then 2 z's. So we leave that all underneath the radical. So then that is our simplified answer. We have no radical left in the denominator, so it is as reduced as we can get it. Alrighty, number 2, again, we try to look at the number 7 divided by 5. They don't reduce evenly, so then we're going to have to go and do our factor tree right from the start. If they do reduce when we can divide, we're going to divide first. But this one, we're going to go ahead and do our factor trees. So for this one, 7 and x is already broken up, 5, and then we have 2 y's, so we can write that separately. And then we need a group of 3 of everything, so we need 2 more 5's, and then we have 2 y's, so we need 1 more y. If we multiply that across the bottom, we need to multiply that across the top too. And then we bring them out in groups of 3. So we have 1, 2, 3, 5, so we bring out a 5. We have 3 y's, so bring out a y. And then we multiply across the top, so 7 times 5 times 5, we get 175. We have an x and a y, so 175x y. And we're going to put it underneath the cube root symbol just because there wasn't 3 of anything, so we couldn't bring anything on the outside. We have no radical left in the denominator, so that is our final answer. Let's do one more of these. So for this one, we have the square root of 3x to the 4th y squared divided by 5xy to the 3rd power. So we're going to go ahead and look to see in our denominator. We have 1, 5, and it's a square root, so I need 1 more. I have 1x, so I need 1 more, and then I have 3 y's. I can bring out a pair already, but then I would have 1 left underneath, so I need to multiply by 1 more y. Since I'm multiplying the bottom by the square root of 5xy, I need to multiply the top by square root of 5xy. And then now I'm going to try to bring everything out in pairs. So I have a pair of 5, so I can bring that out, a pair of x's, so I can bring that out, and then I have 2 pairs of y's, so I can bring that out. And then on the top, I'm going to bring out any pairs that I have. So 3 times 5 is 15. I have 5 x's, 3 y's. And so then since I have 5 x's, I can bring out 2 pairs. So x squared. I have 3 y's, so I can bring out 1 pair. And then I'm going to have 1 additional x and y underneath. 15 is just 3 times 5. I don't have a pair of anything, so then I leave that. So then I can leave this as my final answer, or another way that you can reduce it. Notice you have 2 x's out here and 1 x down in the denominator, so you can reduce that x squared divided by x with just the x. And then I have one y here and two y's here, so I can cancel out one y's in each of them. So then I would be left with one y in the denominator. So that would be my reduced finalized answer.